Alright, John, so hopefully that's going to post and won't have any problem with that. Okay, so that was the 45-degree family, so obviously I think that you're going to see a pattern here. We're going to do pretty much the exact same thing with the 30 and 60 degrees, but the first thing that I want you to notice is you see how we have obviously what we call theta, what we call our angle. That's what we have in the first quadrant. Now that's the one that we know the exact value. I know the exact value of the sine and cosine of 45 degrees. But to figure out what these other angles were, 135, 225, and 315, what we did was we used something that we call reference angle formulas. Okay? So in this quadrant, in the second quadrant, we have 180 minus whatever theta was. So in this case, our theta was 45. Down here we have 180 plus 45, so 180 plus theta. And then in the fourth quadrant we have 360 minus 45. So what we call that are reference angles, reference angle formulas. Okay, so in the first quadrant that's always going to be known as theta. Now theta is always going to be either 30, 45, or 60. Okay, because those are the ones that we're going to know exactly. To figure out what the reference angle is in the second quadrant, you just do 180 minus theta. This one, theta minus 180, we kind of had like a debate about this in class, and then we ended up changing it to 180 minus theta, which is what you and I did on that last screen, and then 360 minus theta. So I have on the back of your plate, I have the reference angle formulas written out just like this. So I would suggest that you do the same thing. Okay, so just write these down so that you have them handy. Really, really, really important. I know that you're probably sick of me saying that something's really, really important, but if I'm moving too fast for you, just pause the video and write this down, but I have to keep going, okay? So we're going to express each of the following as a function of a positive acute angle. I don't really want to do this yet. I think I want to keep moving. Then I'll come back to that. So let's do the 30-degree family because I know you're smart. I'm sure that you're getting the idea of this. So let's just go over our reference angle formulas again. In the first quadrant, we're going to have theta, and theta in this case is 30 degrees. In the second quadrant, that was 180 minus theta. In the third quadrant, we have 180 plus theta. And in the fourth, 360 minus theta. By the time I see you, better have these memorized. Just saying. Okay, so our theta this time is 30 degrees right here. And the magic table that you should have out in front of you, because I don't want you to put that away. I want you to keep it out in front of you. Either the magic table, you can actually do the magic table on the back of the plate too if you want. You can pause and do that right now. You need to have all this stuff. So on the magic table, the cosine of 30 degrees is radical 3 over 2. And the sine of 30 degrees is 1/2. Okay, so see how I have those memorized because I've had to do this a lot. So first thing that I want to do is figure out, remember how we memorized that one and then these are all like the cousins in the other quadrants. So the angle from here to here, how do I figure out what that is? Well, I do 180 degrees minus, in this case, minus 30. 180 minus 30, that is 150 degrees. So the cosine of 150 degrees, because the x's are negative in this case, we're going to have negative radical 3 over 2. And then the y's are still positive, so the y's are positive 1/2. So that tells me what the cosine and the sine of 150 degrees is. See, so it's really helpful to memorize just the 30, 45, and 60, and we could figure out a bunch of the other ones. Okay, so down here in the third quadrant, let's figure out what this angle is going all the way around like that. We can use our reference angle formula, so 180 plus 30 degrees. That will give me 210 degrees. So if you were ever wondering what the sine and cosine of 210 degrees is. Exactly. The whole point is that these are exact values because, all right, yeah, the calculator will tell you what, 1/2 is, but negative radical 3 over 2, it's not going to come up with that value for you. So the cosine of 210 degrees, our x's are still negative, so radical 3 over 2. And then the y's are negative down here as well, so we're at negative 1/2 for the sine. And then last one in this family, we're going all the way around. How do I figure out what that angle is? It's 360 degrees minus 30. So that's 330 degrees. What are the exact values of the sine and the cosine of 330 degrees? You can always pause and try to figure these out for yourself before I start talking. The x's are positive, so radical 3 over 2, and the y's are negative, so negative 1/2. Okay? Pretty easy. Last one, now we're going to do the 60-degree family, so really quick this time. Our theta is going to be 60 degrees. What were the reference angle formulas over here? This is 180 minus 60, or theta. 180 plus 60. And 360 minus 60. Okay, so here is the value that I know. That's my reference angle. And I'm going to use that to figure out all these others. Okay, so take a look back at your magic table. Figure out what the cosine and the sine of 60 degrees are. Cosine of 60 is 1/2. Sine of 60 is radical 3 over 2. Sine of 60, radical 3 over 2. Okay, you should have this written down somewhere because I can't keep going all the way back to that screen. Even though I had to go back to that screen that time, but that's fine. Oops. Okay. So cosine is 1/2, sine is radical 3 over 2. So I'm pretty sure you know the drill by now. Let's figure out what this angle is from here to here. That's 180 minus 60, so we're at 120 degrees. What are the sine and cosine of 120? That would be negative 1/2 positive radical 3 over 2. Down in the third quadrant, all the way right there. Let's see what angle that is. 180 plus 60, so that's 240 degrees. Sine and cosine of 240. Cosine always comes first. Cosine is, the x's are still negative, and this time the y's are negative as well. Okay, and then our last one, all the way around here into the fourth quadrant. 360 minus 60, that's 300 degrees. Sine and cosine of 300. My x's are positive and my y's remain to be negative. Okay? So hopefully that was kind of repetitive for you. Hopefully you're bored and hopefully you understand what I'm talking about. Okay? So now I want to go back a couple slides to this. And we want to express each of the following as a function of a positive acute angle. Whenever it says as a function of a positive acute angle, that means that these angles right here, they live in other quadrants. Okay? They are not acute. They're in the second, third, or fourth quadrant. We want to rewrite these values in terms of the reference angles that are in the first quadrant. Let me make sure I have enough time to do this right now. 4.5 more minutes. Okay. So, let's think about this for a second. Here's what we're going to do. All students take calculus. Okay. Which quadrant is 140 degrees in? Well, it's not in the first one, and it is in the second quadrant. Okay, good. So, what you do now is you figure out, okay, sine is positive in that quadrant. Okay? So when I'm going to rewrite this as an acute angle, that means that, you know, sine can stay positive. That's perfectly fine. So let's just leave it as sine. And then that's when you're going to use your reference angle formulas. Your reference angles are 0. I think I need more space for this. 0, 180 minus theta. Or did I say 0? Sorry. Theta. 180 minus theta. 180 plus theta. And 360 minus theta. So pretty much we know that sine of 140 degrees, that's up here in the second quadrant. So that means that 140 degrees, that's really 180 minus whatever reference angle we were working with here. So this is really the sine of 180 minus theta. Actually, no, I'm probably confusing you at this point. I'm really sorry. Okay, let's try this again. In the second quadrant, the reference angle formula is 180 minus theta. And 180 minus something gave me 140. So what we're trying to do is figure out what that theta is equal to. 180 minus what gives me 140? 180 minus 40 gives me 140. So I can rewrite this as a positive acute angle by saying that the sine of 140 degrees is equal to the sine of 40 degrees. Alright, now that was probably really confusing, so let me try that again for the next one. Okay. All students take calculus. Which quadrant are we in now? Which quadrant is 250 degrees in? 250 degrees is down here in the second quadrant. And that means that cosine is negative down here in the, did I say second quadrant? Oh my gosh. We're in the third quadrant. Cosine is negative in the third quadrant. So what I'm going to do is write a negative sign out front. So I'm going to write negative cosine. And then I'm going to think to myself that in the third quadrant right here, we have 180 plus something gave me 250. So what was that something that I had to add to 180 to get to 250? That would be 70 degrees. So the cosine of 250 degrees is the same thing as negative cosine of 70 degrees. Alright? This one's in my third quadrant. Cosine is negative in the third quadrant. Or, I'm sorry, tangent is negative down here in the third quadrant. So I'm going to write negative tan of, now I look up here at my reference angle formula, 360 minus something gave me 300. So what's that something? That would be 60 degrees. Okay, so I know that was a little confusing. I do have to stop right now, and I will come back and clarify that for you. Okay?